Tiga.
Good evening, Mr. Zulkarnain. Today, we from Group Automata is going to present the MLR analysis of factors that affect medical expenditures. Our group consists of me, Albert, Daffa, Azhad, Ariz, and Rangga. Next, please. So first is the background. So this is how we conduct the research and analysis regarding factors that contribute to the healthcare industry. So the problem is the global expenditure on medical and healthcare is rising at a faster pace. And so we need to analyze key factors that contribute towards medical expenses. So how do we analyze the key factors? First, we conduct a research on possible factors, and then we list the variables and collect data. Then we design multiple regression function, and finally, we conduct the MLR analysis. So the objective of our research here is to use MLR analysis to gain insight regarding significance of each variables on personal medical expenditures and predict future medical expenses based on the known factors. Next, please. So here is the dependent variable of our MLR analysis, which is medical expenditure, and the independent variables, which are age and BMI, which is continuous, and sex, smoking, and region, which is categorical. And then we can conclude the formula to be as listed above. So next, we conduct data cleansing. So in the data cleansing process, we ensure the accuracy and reliability of the data set by handling missing values, duplicate data, and outliers. Next is the assumption test. We ensure that the conditions necessary for valid multiple regression results such as linearity, independence, homozygosity, normality, and no multicollinearity are met. And last, we conduct result validation and analysis. Here we assess the model's predictive accuracy, evaluate its fit to the data, and ensure that it explains the variance in the dependent variable while accounting for the number of predictors. Next, please. So here we conduct the literature review. We can see that from the Global Health Expenditure Database by WHO, the data of healthcare financing data in Indonesia shows an increase of almost 300% from 2009 to 2021. Next, we conducted a literature review regarding linear regression model for predicting medical expenses based on insurance data by Kodian and Francis, 2019. There are some significant factors listed in the journal, such as age, BMI, and smoking. And then we reviewed literature of American Journal of Applied Mathematics and Statistics regarding the assumption test, which is normality, linearity, multicollinearity, and independency test. And we also listed how each test is conducted. Next, please. So the first step of our multiple linear regression, we import necessary library. And so first we import some necessary libraries like Pandas, NumPy, SAT models, Matplot, and Seaborn. And then we also imported mean squared error, head cursor Parkan, and import variance inflation factor. Next, please.
Okay, so for the next step, we load and examine the data, where the data set has 2,038 entries with 7 columns, including age, sex, BMI, children, smoker, region, and charges. Charges insurance cost is the target variable, and the categorical data includes sex, smoker, region will need to be converted to numeric format before further analysis. Okay, so for the step 3, we do the data cleansing, and as shown in the PowerPoint, this is the cleansed data. Okay, so for the next step, that is step 4, it is fitting model for the MLR, where it is divided into 2 initial model and robust model, where the initial model can be affected by outliers and uneven error variance. that could lead to less accurate predictions, while the robust model use log transformation to stabilize error variance and minimize outliers impact, improving prediction accuracy and reliability. And then we have step 5, where we do a normality testing, where the residuals are mostly normal with minor deviations in the tails. This is common and should not affect multi-linear regression model, and no further action is needed.
Okay, so for the sixth step is the linearity check. So for the coding, and then we can see the residual versus the weighted values. However, the interpretation is the residual versus weighted value. Valid plot shows some non-linearity, but since our focus is on the predictive performance, this minor issue likely won't impact accuracy significantly. Given the good fit from the log transformation, it's reasonable to accept this limitation. And then for the homicide check, we can use this coding, and the brush pagan test indicates the heterogeneity with a small p-value. However, with the application of log transformation and heterogeneity robust standard errors, the issue is accounted for. Our model's standard errors, p-value, and confidence interval remain reliable, meaning the interface and prediction are still valid despite the non-constant variance. And then the eighth step is the independence error check. So here the coding, and then the Durbin-Watson statistic is 2.05, which is very close to the ideal value of 2 or the number of 2, which is in the range of 1.5 until 2.5. So this indicates there is no significant auto correlation in the residuals, meaning the error terms are independent. Therefore, the assumption of independent errors in our model is satisfied. And then the multicollinearity check, and then the variance inflation or the VIF values for all variables below 2, indicating there is no serious multicollinearity in the model. Since a VIF above 5 or 10 typically suggests problematic multicollinearity, this result confirms that the predictors in our model are independent enough to ensure reliable coefficient estimates.
Okay, so we're going to the model evaluations. Here we know that the RMSE, or mean square error, of the log transform data is 0.6465, which perform better than the original, which are 8436. This by reducing the impact of skewed data, so which are resulting in the adjusted R square of 0.7216, which state that the model provides a good fit. Next. Then we go to the model summary. Here we know that the model is explained over 72% of the variance in medical charge, and the key variables like age, BMI, children, and smoker status are considered as significant as the p-value is less than 0.05, with age and smoker being the most impactful because the coefficient is high. And then the use of HC1 or heterogeneity robust standard error ensure reliable estimates, confirming the model effectively captures these relationships. And then we go to the model predictions. So here are the example of the predictions used on the model. So here on the predicted charge are 12,339, where the actual charge is 12,644. This is show that there are small prediction error, which demonstrate that the model performs really well. So here are the results analysis. So the model fit is for the R square is 0.723 or 72.3%, and the adjusted R square is 0.0722, which are 72.2%. And then the F statistic is 41.9 with a p-value of 0. And then the diagnostic is for the omnibus test and Jar-Kubera, which both tests show p-value close to 0, which suggests that the non-normality in residuals with a right skewed and heavy tail distributions, which are normals in real data. And then for the Rabin-Watson's is 2.0, 4.05, and 0, which are close to 2, and there's no significant autocorrelations. And the covariance step used are the HC1 or heterogeneity robust standard.
Okay, thank you, Alip. So, this is the results of the analysis of the robust model performance and key predictors. So the constant is the intercept at 7.05, and this is the baseline level of charges when all predictors are 0. And then we have the age factor, which is each additional year in age increases charges by approximately 3.3% in the log transform scale in the robust model. And also the each unit increase in BMI or body mass index increases charges by about 1.52% in the log transform scale. Next slide, please. And then the robust model also predicts the children, and each additional child increases charges by about 10.11%. The sex, males on average, is 7.27% having a lower medical charge than females. So this effect is only moderate. And the biggest effect is a smoker has the largest impact, with smokers incurring charges that are 153.42% higher than the normal one. Next slide, please. And also we have the several regions in the United States here. In the Northwest, they have minus 0.0517, although this is non-significant reduction in charges. We also have a Southeast region with 9.63% reduction in charges, which is statistically significant. And also, this is the biggest one in the Southwest region. We have 14.65% reduction, and it is statistically significant with p-value of less than 0.001. This suggests that certain regions have a lower healthcare costs than others, as you can see in the map here. And so what can we conclude from this? So with the adjust R squared of 0.722 or 72.2% of the variation in medical expenses is explained by the selected variables, confirming a strong fit between the model and the data. Also, the F statistic of 544.7% with a probability value of 0.0 indicates that the overall model is statistically significant. And then for the higher R squared and the significant F statistic collectively demonstrate a strong and reliable correlation between the chosen predictors and the medical expenses, confirming the model's validity in capturing the key factor that drive medical costs. So what can we conclude? So age, body mass index, number of children, and smoker status are significant predictors of medical expenses, with p-values indicating strong statistical significance with a p-value of less than 0.05. The robust model accounts for 72.2% of the variance in medical charges, underscoring its effectiveness in identifying the key cost driver. And then we have an example here. So we have a female with age of 60 and a body mass index of 35. Her predicted charges are $12,339, and the actual charges are $12,644. So what this means is that there's a small prediction error, which indicates that the demonstrate is performing well due to the slight numbers resulting in slight differences. So the differences is only around 2%. Next slide, please. Okay, so here are our references, and this has been Automata Group. Thank you. Yeah.
This has been Albert.
This has been Rangga.
This has been Ariz.
This was Alif.
And this has been Daffa. Thank you for your Pak Zul's attention, and also your very high curiosity, and also your I will really thank you for your expertise and also your guidance throughout this OTS. Thank you, and this is Automata. Thank you, Pak.
Thank you, Pak.